Good evening. So let's start our live interaction session for week 7 for our course Biomechanics by Professor Bharathan from Department of Applied Mechanics and Biomedical Engineering, IIT Madras. I am your TA, Manjunathan, a research scholar from the Department of Applied Mechanics, IIT Madras. So, hope you have gone through week 7 videos. Comparatively, it's a basic topics have been covered in week 7. Mostly the topics you might have learned from previous schools and also from any graduate courses. So, in week 7, topics are mainly about on the types of tissues, and the week 7 video starts with the brief introduction about types of tissues, and then moving on to uh, and how the hard tissues like bone and uh, its constitution, how bone is constituted, what is the structure of bone and properties of bone, and how we can apply our rules of mechanics to a biological tissue like bone. So here the course discuss about what's the structure of the bone, how uh, the bone is being generated or made, how it is sustaining the loads that is being applied to it uh, from body or the external loads. Hope you have seen the video. So mostly we will be starting with a small recap of the course. So since the topics were uh, simple, I am not going to much detail of the courses. I mean, of the content, course contents. So mostly the week 7 lectures circles around how bone is constituted and the properties of bone, how or which properties of the bone or how the constitution of bone helps the bone uh, in handling the loads. Even if that load is our body weight or any external loads. So what you see here is a Haversian system or osteon of a bone. These are the different components of the bone. We will be discussing about each. I mean, we will be taking questions on each parts moving forward. I'm just showing the things so that you can recollect and refresh your memory of the course videos you have gone through. And also in this course, in this week, the course is discussing about the mechanical stress strain behavior, how the basic mechanical properties like stress and strain uh, is calculated in bonds and how it behaves under loads. So this basically the stress and strain is two fundamental properties of any mechanical fundamental mechanical properties of any material that we study. So the same theory by which we are studying column struts, any rigid metal components, wood or anything. Similarly, we have also analyzed bonds in the mechanical point of view. Hope we can start with the questions directly. This week's questions will be mostly fundamental questions due to the course content itself. So let's start with the questions. First question: Which type, which tissue type is primarily responsible for generating force and movement in the body? Options are: option A, nervous tissue; option B, muscle tissue; option C, connective tissue; option D, epithelial tissue. The question is asking which tissue type is primarily responsible for generating force and movement. So this we have already discussed in previous weeks. Try to answer the question. Options are: option A, nervous tissue; option B, muscle tissue; option C, connective tissue; option D, epithelial tissue. Yes, option B, muscle tissue. Uh, we have seen how the sliding in the previous weeks, how muscle tissue has contractile proteins like actin and myosin, and the stick sliding filament theory, by which theorizes how force is being generated inside the muscle tissues. So our answer is option B, muscle tissue. Next question: Which tissue type provides structural support and mechanical strength to organs? Next question: Which tissue type provides structural support and mechanical strength to organs? Options are: option A, epithelial; option B, muscle; option C, connective; option D, nervous. Options are: option A, epithelial; option B, muscle; option C, connective; option D, nervous. Yes, answer is option C, connective tissue. So, the first choice that will be coming to your mind will be, when hearing structural support, the bone will be the choice that will be coming to your mind. But bone is a specialized type of connective tissue, and along with bones, cartilage, ligaments, everything is connective tissue. These tissues provides mechanical support and structure to the body. Next question: Which of the following connective tissues primarily resist tensile loads? Which which of the following connective tissues primarily resist tensile loads? we can rephrase the question like which is the which of the following connective tissue primarily bears the tensile load. Which of the following connective tissue primarily resist tensile loads? So from the given option, tendons, option D are the right choice. Tendon may primarily bears the tensile loads. So mainly there are three types of loads which are tensile, compressive, third one shear. So tensile is the force that is, suppose this is the one element, then the applied force is acting like pulling it apart axially if the load is aligned to its axis, and also it is kind of pulling it from both sides. Then such kind of loads are called tensile loads. And tendons which connects bone to bone, such structures are mostly the ones that is primarily bearing tensile loads. Next question. Which property of the connective tissue mainly arises from collagen fibers? Options are option A, compressive stiffness, option B, tensile strength, option C, electrical conductivity, option D, plastic deformation. This property of the connective tissues mainly arises from the collagen fibers. An easy question. Which property of the connective tissue mainly arises from collagen fibers? Is it compressive stiffness or tensile strength or electrical conductivity? D, plastic deformation. Yeah. If you have from last question itself, it is evident that the collagen fibers gives tensile strength. That is option B. Collagen fibers are major components of connective tissue which primarily offers tensile strength. Next question. The fundamental structural unit of a compact bone is called what? The fundamental structural unit of a compact bone is called what? Options are option A, osteon, option B, trabecula, option C, canaliculus, option D, lamellae. The fundamental structural unit of a compact bone. Option is option A, osteon. Osteon or the Harvation system is the primary structural unit of compact bone. So that here itself. So this outer peripheral portion of the uh, bone is known as compact bone, and here these are uh, osteons or Harvation systems. So these Harvation systems is the fundamental unit for compact bone. This is osteon. Next question. Which biological tissue primarily resists compressive loads? Before it was tensile loads, now it is compressive loads. Which biological tissue primarily resists compressive load in joints? Options are option A, ligament, option B, cartilage, option C, tendon, option D, muscle. Which biological tissue primarily resists compressive loads in joints? Which biological tissue primarily resists compressive loads in joints? Answer is option B, cartilage. So, if you remember, in last sessions, we have discussed about knee joint and all. There, in knee, there was meniscus, lateral and medial meniscus was there. So, this is one such cartilage. Uh, uh, Lateral and medial meniscus are made of fibrocartilages. So these kind of cartilages are just situated in joints help in resisting compressive loads. So like what we have seen, what is tensile load, like that. Suppose uh, this one structure, then there is load, the load is kind of compressing, crushing it from both sides, and it is, if it is axially located, it is parallel to the axis of that particular member, then it is known as a compressive load. So when in joints, so there will be one layer of cartilage, some cushioning uh, cartilages will be there for almost every joints, so that the bone should not be come in direct contacts. So these are the structures that will help reduce the wear and tear in the joints. Also resist the compressive loads, because when both under movements and load taking, these bones, the forces from the bones will be coming in the direction of the joint. So there some cartilage cushions will be uh, there to reduce the wear and tear of the movements. Next question. Cells are responsible for bone formation. So which among the following options are the cells responsible for bone formation? Options are option A, osteoclast, option B, osteocytes, option C, osteoblast, option D, chondrocytes. So, which among the following cells are responsible for bone formation? Option A, osteoclast, option B, osteocytes, option C, osteoblast, option D, chondrocytes. Answer is option C, osteoblast. So these are uh, osteoclast, osteocytes, and osteoblasts. These are uh, three main cell types that remodel a bone tissue, and in which among these three, osteoblasts are the uh, cells that synthesize and mineralize the bone matrix, also known as the formers. Since this form, uh, these types, I mean, osteoblasts are the cells responsible for formation. They are also known as bone formers. Next question. The central canal of an osteon is known as what? The central canal of an osteon is known as what? Options are option A, Workman's canal, option B, Harvestian canal, option C, lacunae, option D, canaliculus. So if you can recollect what's the other name for an osteon, you can easily answer the question. Options are option A, Workman's canal, option B, Harvestian canal, option C, lacunae, option D, canaliculus. His answer is option B, Harvestian canal. The other name for the uh, osteon is Harvestian system, and the canal is known as Harvestian canal. And this Harvestian canal contains blood vessels and nerves. And this is the passage designed for conducting blood vessels and nerves. Next question. The mature bone cells located within the lacunae are called as what? Options are option A, osteocytes, option B, osteoblast, option C, osteoclast, option D, fibrocytes. The mature bone cells located within lacunae are called as what? Options are option A, osteocytes, osteoblast, osteoclast, fibrocyte. Osteocytes, that's our answer. Osteocytes are the mature bone cells located within lacunae, and these osteocytes maintain the bone tissue and maintain the regular content, uh, mineral content, regulate the mineral content, and the word itself, these maintain. So, like we have osteoblasts, which are formers, like osteocytes are called maintainers. So, osteocytes are called maintainers, and these osteocytes are mature uh, uh, bone tissue which has trapped osteoblast, which can sense mechanical stress. Next question. Cell responsible for bone resorption are option A, osteoblast, osteoclast, osteocytes, and fibroblast. Which cells are responsible for bone resorption? Which cells are responsible for bone resorption? Option A, osteoblast. Option B, osteoclast. Option C, osteocytes. Option D, fibroblast. Yes, our answer is option B, osteoclast. We have already seen osteoblast and osteocytes. This question is on bone resorption. So these are done by osteoclast. These osteoclast break down the bone tissue during remodeling. These osteoclast will break down the large, large multinucleated cells from monocytes or macrophages using acid or enzymes. So osteoclasts are the cells responsible for breakdown bone tissue during remodeling. Next question. Bone is classified as which type of material? So from mechanical point of view, what is the type of material that the bone is considered to be belong to? Options are option A, isotropic, option B, homogeneous, option C, anisotropic, option D, perfectly elastic. Bone is classified as which type of material? Options are isotropic, homogeneous, anisotropic, perfectly elastic. Yes, answer is option C, anisotropic. Bone is classified as anisotropic material. So, isotropic isotropic materials are materials that will show or exhibit the physical properties in same physical properties in all direction. Suppose if we are taking one cubical element, imagine this as a cube. So in x, y, and z direction, if the mechanical properties like uh, strength, mechanical strength, yield strength, all those things, or conductivity, such properties, if all those properties are same in all direction, that is, if it is some value uh, in x direction, it will be having the same value in y direction also. So if such a behavior is shown by a material, then such materials are known as isotropic materials. This mostly is an assumption for most of the uh, mechanical uh, elements for analysis. But anisotropic is the opposite of isotropic, where the properties will vary. Physical properties will vary according to the direction. Such materials are known as anisotropic materials. Homogeneous material is, I think everybody knows what's homogeneous. Homogeneous is the combustion. If one particular material has uniform combustion throughout the that particular material, then it is known as homogeneous. And perfectly elastic is that we will discuss in coming questions. So Let's understand what is these terms are. And bond comes under the category of anisotropic material because bond properties vary depending on the loading direction. Next question. Which structure connects lacunae and allows nutrient exchange between osteocytes? So, which structure connects lacunae and allows nutrient exchange between osteocytes? Options are option A, lamellae, option B, canaliculi, option C, trabeculae, option D, periosteum. Which structure connects lacunae and allows nutrient exchange between osteocytes? Option B, canaliculi, is the right answer. Option B is the right answer. And canaliculi is the system of canals, interconnected canals or channels that is there, which communicates between osteocytes. So our answer is option B, canaliculi. Next question. Which property describes bone's ability to absorb energy before fracture? So, which property describes bone's ability to absorb energy before fracture? Options are option A, toughness, option B, elasticity, option C, ductility, option D, hardness. This property describes bone's ability to absorb energy before fracture. These are mechanical properties. Answer is option A, toughness. Toughness is the mechanical property that uh, relates with the ability to absorb energy. And you know what is elasticity? Elasticity is to regain the original shape when the load is removed. And ductility is the ability to uh, plastic deformation or wire drawing. Like we can stretch it into wires and bend it, twist it without breaking. Such materials are called ductile materials. It can continuously deform without breaking. Such materials are called ductile materials, and hardness is actually a surface property. So mostly these are the two words that get confused between hardness and toughness. So hardness is only a surface property. If suppose one surface is very impenetrable, that kind of surface is known as hard surface, whereas the toughness is the ability to absorb energy. So these are the two things that can get confused: hardness and toughness. Always let when say something is when you hear something is hard, remember that its surface is kind of impenetrable. Next question: which property describes bond's resistance to deformation? Options are: option A strength, option B stiffness, option C toughness, option D plasticity. Which property describes bond's resistance to deformation? Correct answer is option B stiffness. Strength, you know what is strength? Stiffness is the ability to resist deformation when something is loaded. Toughness, we have already discussed what is toughness, and plasticity is the ability to deform continuously. Plasticity is the ability to deform continuously without breaking. Here the answer is stiffness, that is the resistance to deformation under load. Next question: compared to cortical bone, the trabecular bone has dash. Options are: option A higher density, option B lower porosity, option C lower stiffness, option D high elastic modulus. Compared to cortical bone, the trabecular bone has which among the following? The answer is option C lower stiffness. Here the cortical bone is nothing but the compact bone, and this is the spongy bone. So the trabecular bone has more uh, tuberculate, that is, it has more porosity, and so since it is more porous and this it offers less stiffness. Our answer is option C, lower stiffness. Next question. The trabecular bone primarily experience which among the following? Options are option A, tensile loading, option B, compressive loading, option C, shear loading, option D, torsion only. Yes, the answer is option B, compressive loading. Because we have just discussed tubercular bone is most porous, and porous uh, porous what materials can take compressive loading because it has space to compress. It will be there are space between them, so it is well equipped for compressive loading. So the spongy portion, the spongy bone, that is the trabecular bone, is mostly optimized for compressive forces or compressive loading. Answer is option B. Next question. Hooke's law describes the relation between the basic mechanics question. What is known as Hooke's law, or Hooke's law constitutes the relation between which among the following? Options are stress and strain in the elastic region. Option B, stress and time. Option C, strain and energy. Option D, force and density. Simple question. Hooke's law describes the relationship between what? Yes, answer is option A, stress and strain in the elastic region. Hooke's law lives between the stress and strain in the elastic region. So this is the stress strain behavior where stress acting on a stress induced on a particular material is plotted against the strain. That is the rate of deformation. So this is the graph stress strain. This is known as the stress strain curve. And here you can see initial some point it is having a straight line. this is called proportionality uh, limit or proportionality region. From 0 to a, this is called proportionality. This much portion is called proportionality limit. Here, this stress will be directly proportional to strain. That's why we are having a inclined line. So in this region, the Hooke's law is applicable, and Hooke's law itself states the stress will be directly proportional to strain. And beyond that is the elastic limit. Even though there is some materials will vary little away from the proportionality rule, but it will be still be elastic. That is, it can regain its shape after removal of loading. And that is this A to B. So if you search for stress strain curves, you will get different for different material. The stress strain curve will be different. So some materials, the proportionality point, that's A and B, will be matching, but some materials it will be having different proportionality limit and elastic limit. That is, uh, if we are continuously loading beyond the proportionality point, uh, the strain won't be in proportional to stress occurred, but it will be still be elastic. But after the elastic limit, it will start to deform. The rate of deformation will be much higher than that of the load applied. That proportionality won't exist, and after some point, that is a yield point, it will start to uh, deform. That is, at some point, it will start to deform, that it cannot regain its shape after the after that point. So that is known as plastic behavior. And even after that, if you are continuously loading, it will at some point it will the material failure will occur, and at which point the material failure occurs, that is known as the breaking point. So this is the simple stress strain curve for a example material. You can if it is a ductile material, you will get one particular stress strain curve. If it is a brittle material, you won't be seeing these limits, it will break. So depending on the type of material, the stress strain curve will be different. So in our question, Hooke's law correlates between the stress and strain in the elastic region or proportionality region. Answer is option A. Next question, Wood's law. Wood's law states that option A, bone density decreases with load. Option B, bone adapts to mechanical stresses. Option C, bone behaves plastically. Option D, bone strength is constant. What does Wood's law states? Answer is option B. Wood's law states that the bone adapts to the mechanical stress it is exposed to. So Wood's law is one particular theory in bone formation and bone maintenance, where the theory says the bone will remodel according to the mechanical loading patterns that is exposed to. Next question. According to Wolff's law, the reduced mechanical loading leads to which among the following? Options are option A, bone hypertrophy, option B, increased stiffness, option C, increased mineralization, option D, bone resorption. According to Wolff's law, reduced mechanical loading leads to which among the following? Options are bone hypertrophy, increased stiffness, option C, increased mineralization, option D, bone resorption. The answer is option D, bone resorption. So, in according to Wolff's law, uh, when uh, when the bones are exposed to higher loads, it will get stronger. Wolff's law simply states that higher loads bones become stronger, decreased loading weaker. And this is basically what Wolff's law states. So, by weaker meaning the bone is kind of bone minerals are reabsorbed to the body, causing uh, bone loss. So simply the word bone resorption is called as bone loss, and bone hypertrophy is called enlargement. The enlargement of bone is known as bone hypertrophy. Increased stiffness is actually uh, due to the high mineral content. In old ages and all, the mineral content in the bone will increase, and that will cause increased stiffness. So this B and C are correlated. So increased mineralization will lead to increased stiffness. It will become less in collagen but higher in minerals. So such a condition is known as uh, bone mineralization, or which will lead to increased stiffness. So here the answer is bone resorption. That is, under reduced loads, the bone losses will occur. So that's why weight training is become weight training, or such activities are required for the body, so that the body bone loss should not occur. Moving on to next question. The proportionality constant in Hooke's law is called. It's a simple question. What is the proportionality constant used in Hooke's law? Options are option A, elastic modulus, option B, yield strength, option C, toughness, option D, plastic modulus. what is the proportionality constant used in Hooke's law? Right answer option A, elastic modulus, or known as Young's modulus. The constant in Hooke's law is known as Young's modulus or elastic modulus, which to, which is used to remove the proportionality between stress and strain. Next question. Hookean behavior in biological tissue is valid primarily in which region? Options are option A, plastic region, option B, failure region, option C, elastic region, option D, necking region. The Hookean behavior in biological tissue is valid only in or valid primarily in which region? Options are option A, plastic region, option B, failure region, option C, elastic region, option D, necking region. Answer is elastic region because Hooke's law only applies in the elastic region. So here just added biological tissue, but Hookean behavior is general law for materials which is only applicable on elastic region. So whatever be the material, the Hookean behavior will be exhibited in elastic region of that material. Next question. Stress is defined as. So what's the definition for stress among the following options? Simple question only. Options are option A, force into area, option B, force by area, option C, area by force, option D, force into displacement. So which among the following is good definition for a stress, mechanical stress? Yes, answer is force by area. Stress is equal to F by area. That is actually stress is the internal resistance developed because of an external applied load. That's the basic concept. Suppose this is some material and it is being pulled apart axially. That is, it is subjected to tensile load. So, if we are creating a cut section here, so what is the internal resistance developed for this load? Because it is there only, the stress is only there if at all there is a load acting. Suppose P is the this particular material is pulled apart uh, in both directions with same uh, force P, then that force divided by the cross-sectional area of this particular material, that is the stress developed. And stress only stress is stress only exists when there is an external applied force is there. So it's an internal resistance developed because of an external applied load. So mostly we will be studying what is stress, but this is the actual concept of force. This is the internal resistance developed because of an external applied load. Next question, what is strain? Strain is defined as showing the following. Options are change in length by original length. Option B, lengthwise stress. Option C, strength stress into length. Option D, force by deformation. What is the definition for strain? Option A, change in length by original length. Option B, length by stress. Option C, stress into length. Option D, force by deformation. Yes, answer is option A. That is rate of change of uh, dimension is rate of change of deformation is known as strain. So, it not just length, any property with respect to the original change in that actual dimension to the original dimension, that is known as relative deformation or rate of deformation, and strain is the time that we use for relative deformation. Suppose strain eta is equal to delta L is the change in length by L was the original length. Suppose this was the original length and it was some force P applied on this both ends, and this component increased in its length and the change in length is delta L, then strain is delta L by L. These are simple questions only. Which stress acts parallel to the surface? Options are normal stress, shear stress, compressive stress, tensile stress. Which stress act parallel to the surface? The answer is option B, shear stress. Shear stress is the stress that acts parallel. Suppose this is a surface and if we are applying one force parallel to the surface, then the stress developed there is known as shear stress. And compressive stress and tensile stress are two examples for normal stresses. That is the stress that is acting normal to a surface. So these are two types of normal stresses. Tensile and compressive are two types of normal stresses, while shear stress is the stress that act parallel to the surface. Shear stress act tangentially to the surface. Which type of stress occurs when forces pull a material apart? I've already discussed this one. Which type of stress occurs when forces pull material apart? What is the pulling force? Options are option A compressive, option B shear, option C tensile, option D hydrostatic. Yes, the answer is C tensile force, and hydrostatic force is the force that is acting upon a body that is immersed within a fluid. So when some body is immersed within a fluid, the fluid will exert force on all the surface of that particular body, and which will result in a stress known as hydrostatic stress. Next question. Young's modulus is obtained from. Options are option A area under stress strain curve, option B slope of elastic region, option C yield stress, option D fracture stress. So from where we can find Young's modulus or elastic modulus? Options are option A area under stress strain curve, option B slope of elastic region, option C yield stress, option D fracture stress. The answer is option B, that is the slope of elastic region. So here we have already discussed what is so this is the uh, portion which has this is the proportionality limit where Hooke's law is applicable, or within the elastic limit. We already told that uh, stress is proportional to strain. It is sigma is proportional to eta. So the slope, if we are taking the slope of this elastic region. So this portion will give the stress and this will give the strain. So simply this sigma y. So when according to Hooke's law, sigma is equal to E by E into eta. That is where E is the Young's modulus. So rearranging E is equal to sigma by eta. That is the Young's modulus is given by the slope of stress strain graph. That is the slope of elastic region. The area under stress strain graph, area under the stress strain graph, if it is within the elastic region, it gives resilience, something called as resilience. Resilience is the stored energy which will help to regain its original shape. So that is the area under the stress strain curve gives if it is within the elastic region, and beyond elastic region it gives toughness. So this is what you get from the area under stress strain graph. If the area under the graph in the elastic region will give you resilience, and beyond elastic region it will give the toughness. The point where permanent deformation begin is called. Options are: option A, ultimate stress; option B, yield point; option C, fracture point; option D, elastic limit. We have seen that point in the graph just before. The point where permanent deformation begin is called what? Options are: ultimate stress; option B, fracture point; option C, elastic limit; option C, fracture point; option D, elastic limit. Yes. The question is the point where permanent deformation begins. Option is option B, yield point. Option B, yield point is the point where permanent deformation begins. Beyond elastic limit, there's a point where, so beyond elastic limit, there's a point known as yield point from where the permanent deformation begins. So here, the yield point marks the transition from elastic to plastic deformation. So within the elastic limits, uh, the deformation can be undone, but in plastic deformation, the deformation in plastic zone, the deformation is permanent. Next question: the maximum stress which a material can withstand before failure is known as what? Options are option A, yield strength, option B, elastic modulus, option C, ultimate strength, option D, toughness. The maximum stress that a material can withstand before failure is known as what? Options are option A, yield strength, elastic modulus, ultimate strength, toughness. Is option C, ultimate strength. This is the maximum stress which a material can withstand, and this will be the peak of the stress strain curve. This is the peak most point indicated by the stress strain curve. Next question. The area under stress strain curve represents. I just explained in one question before. Options are option A, elastic modulus, option B, toughness, option C, yield stress, option D, stiffness. Try to pick the option which is given. Options are option A, elastic modulus, option B, toughness, option C, yield stress, option D, stiffness. What does the area under stress strain curve represent? Answer is option B, toughness. So the area under the curve is equal to the energy absorbed before fracture. So we are making stress and strain. This this area, that is area under the curve in the elastic region, will give the resilience, and this area will give toughness, because this is the uh, area under the curve which in the plastic deformation, and it amounts to the total energy absorbed before fracture. This is the point where material fails. Next question: which region of the stress strain curve represent reversible deformation? Simple question. Which region of the stress strain curve represent reversible deformation? Options are option A, plastic region, option B, necking region, option C, failure region, option D, elastic region. the deformation is only reversible within the elastic limit, that is the elastic region. Option D is the answer. Option D, elastic region, is a region where the deformation is reversible. That is, the change in dimension or the deformation will disappear once the load is removed. Next question. Biological tissues often exhibit which mechanical behavior? Options are: option A, perfectly elastic; option B, viscoelastic; option C, perfectly plastic; option D, isotropic linear behavior. So, what is the common behavior shown by biological tissues? Options are: perfectly elastic; option B, viscoelastic; option C, perfectly plastic; option D, isotropic linear. Answer is option B, viscoelastic. That is, it shows biological shows both viscous and elastic. So, simple stress strain curve for a viscoelastic material will be, it won't be linear, it will be something like a curve. It is for loading, this is for unloading. So, this something like this will be a curve for viscoelastic materials. So, that is viscous, that is, it will resist shear and it will regain shape within the elastic region. So, uh, uh, biological tissues mostly exhibit these two properties combined. That way, it is accounted under a particular category known as viscoelastic. A lot of polymers seen in the nature and also the artificial polymers comes under viscoelastic category. And this time dependent behavior. So, you may be wondering what is time. Stress by time. The stress by time graph will be something like this for a viscoelastic material, whereas it will be a straight line for uh, elastic material or other materials. So, some curved graph that is eventually attaining a straight line. That is what time dependent behavior or time dependent. That's with respect to time, how the stress, the applied stress. I mean, I already told you the stress is what the internal resistance for the applied load. So, if the same load is applied, then with respect to time, what will happen to the internal resistance? That is what time dependent behavior. So, this will be some. This is a graph, but typical graph for uh, uh, what viscoelastic material. This is stress versus time, and strain versus time will be something like this. Next question. Bone behaves more brittle when? When does the bone behaves more brittle? Options are option A, loaded slowly, option B, hydrated, option C, loaded rapidly, option D, at low strain rate. When does the bone behave more brittle? This answer is option C, loaded rapidly. Bone behaves more brittle under high strain rates. So when there's an impact loading or rapid loading is done on bones, it will act more like a brittle material. Next question. When the bone bends, the outer surface of the convex side experience what? When the bone bends, the outer surface on the convex side experience what? Options are option A, compression, option B, torsion, option C, shear. Sorry, there is two. Okay. There is an error in the question. There is no right answer for that. So can you give the right answer? When a bone bends, the outer surface of the convex side experience what? The question doesn't have a right answer actually. Can anyone give the right answer? I have not listed some error code and I have not listed the actual answer here. Okay, the correct answer is tensile. It should be tensile. That is the correct answer. Option D was not there. So suppose this is a bone and this is the convex side and concave. I'm just showing a bone head only. So on when it bends, so this portion will be having stretching and this will be having a compression. So the convex side will be having a tensile load and the concave side will be having a compressive load. So answer is tensile. When bending occurs, the convex side happens. The convex side experience a tensile stress. So even if you take it as a simple beam, just take this as a simple beam, and it is kind of bent with I am acting one particular load here, so it will its tendency will be to bend. So the outer surface has to stretch more and inner surface has to contract. So where the tendency to contract is there, there will be compressive stress will be driving that tendency, and the tendency to expand will be driven by tensile stresses. So convex sides will be experiencing tensile stress. You can simply answer this one. The concave side of the bending bone experience what? Options are option A tension, option B compression, option C shear, option D torsion. Answer is option B, that is compression. That is the we have already seen that the convex side will be experiencing tensile and concave side will be experiencing compression. Option B. Next question. The region within a bent bone that experience zero stress is called what? Options are option A neutral axis, option B shear plane, option C yield plane, option D stress plane. The region within a bent bone that experience zero stress is known as what? Okay, so imagine this is a bent bone. So there is one region in the middle, mostly in the middle, known as option A neutral axis. So that's the region where which experience zero stress. So this neutral axis is the region or the axis which separates the uh, compressive and tensile regions. So here it is compressive, that is the concave region is compressive. Here it is tensile. So where the tensile, so if we are going from outer to inwards, so where the uh, stress reverses, that region is known as neutral axis and it experiences zero stress because it is if suppose we are taking tensile stress are positive and compressive was negative, then this at this uh, neutral axis there is a sign change. So you know where's the location where the sign change happens there, that is zero. So it's a zero stress region known as neutral axis. It is not just for bone. Any material when experiencing a bending, there will be some region called neutral axis. Next question. Which factor more strongly increases the bending resistance of a bone? Which factor most strongly increases bending resistance of a bone? Options are option A, bone length, option B, bone diameter, option C, bone density, option D, muscle force. Which factor most strongly increases bending resistance of a bone? The answer is option B, bone diameter. So that is pretty intuitive. That is when if you are think about bending two materials of same length but different diameters. So the one having the larger diameter will be difficult to bend. So from given options, bone length, that is increased length, will uh, give will help in bending. Actually, it is in favor of bending, while bone diameter is against that. Next question. Bending stress in a beam is proportional to what? Options are option A, distance from the neutral axis, option B, bone length only, option C, material density, option D, cross sectional area only. The bending stress in a beam is proportional to what? Answer is option B, sorry, option A, distance from neutral axis. Suppose if you imagine this is a bend structure and this is the neutral axis. This is the neutral axis. The distance from neutral axis is something what that is proportional to bending stress. As the distance from neutral axis increases, the bending stress also increases. Stress increases or bending stress increases with distance from the neutral axis increases. Next question. Which type of fracture is commonly caused by repeated bending? So what is the type of fracture that is caused by repeated bending? Options are comminuted fracture, option B, stress fracture, option C, spiral fracture, option D, green stick fracture. Which type of fracture is commonly caused by repeated bending. Answer is option B, stress fracture. Stress fracture, stress fractures are the fractures that is occurring due to repetitive bending loads. So these are different types of fractures where this uh, comminuted fracture is also known as complex fracture, where the bone uh, breaks into three or more pieces is what comminuted fracture is. Stress fracture is something that is happening due to uh, repetitive stress loading, sorry, repetitive bending, and whereas spiral fracture is something, suppose this is a bone, so one portion twist like this and another portion twist like this. That is due to twisting, spiral fractures can occur. Twisting fracture. And green stick fracture is something that is uh, it is not actually it is a something known as some incomplete fracture. Suppose imagine this is a bone and there is some fracture in one side. So there is chipping fracture or something like that. Then such fractures are known as green stick fractures. So it's not a complete fracture. That's where the uh, bone completely snaps away, but it just breaks. Suppose uh, uh, by bending some portion, here's a crack, because due to some bending or something, one particular portion has a crack, but other it is not completely snapping away. It's completely not slipping away or uh, getting apart. So such kind of fractures are known as green stick fractures. Next question. Long bones are structurally optimized to resist bending because they are, options are, option A are solid structures, option B have hollow tubular geometry, option C are isometric, option D have uniform density. Long bones are structurally optimized to resist bending because they have, option A solid structures, option B have hollow tubular geometry, option C are isotropic, option D have uniform density. answer is option B, have hollow geometry. Have hollow tubular geometry. So, since the long bones are having tubular shape, which will we have discussed in previous question that increased diameters will give uh, it is with increasing diameter the difficulty to bending occurs. That is, it maximizes the bending stress, and the hollow tubular shape will reduce the mass. So long bones are optimized by having hollow tubular geometry. Option B is the right answer. So that's all for today. Thank you for joining.